All right, guys, good afternoon. So we're back to the linear programming, linear inequalities. And as I said, our aim is to get to linear programming, which really is an application, a real-life application of simultaneous linear inequalities. And I'll explain it a bit when we get to when we get to that stage. But first, we're going to look at simultaneous linear inequalities. So what we did yesterday was to look at we looked at inequalities one at a time yesterday. That's what we did yesterday. So here, for example, we did this one, which was just one inequality we're working with, right? And we ended up explaining how we do it, draw the graph, the line, how it worked out when we must draw a broken line versus when we must draw an unbroken line, when it's above, when it's below, stuff like that. And then we looked at how we could actually show it on a graph. So the procedure is to draw the line and then label the line with the equal sign and then shade the graph, shade the side of the graph, depending on whether you want above or below. And the line is drawn broken or unbroken, depending on whether the equal is included in the inequality or not. All right, I've explained all of that and I spent a good bit of time yesterday on that. So we're gonna apply all of that in some questions. So I'd have to recap that right now. So that's an example. And that's just one line, and so you have that one big shaded area above the line. Now 6, you won't ask you to just do one line and shade above one line. They hardly ever ask that. What they'll more likely give you to do is this: simultaneous linear inequalities. Now, simultaneous means occurring at the same time. So we're talking about linear inequalities occurring at the same time. And so we're talking about, for example, if there are 3 lines, then there are 3 regions. And the simultaneous is referring to the region, the one region where all 3 inequalities overlap each other. All right. When we do simultaneous equations, not inequality, no, simultaneous equations, we basically search for point of intersection of lines, like 2 lines, or we're trying to find that point. That's when we solve simultaneous equations. Now we're talking about simultaneous inequalities. And so we're talking about, for example, if you have 3 lines, and then you have a region that is common to the 3 lines, 3 inequalities, I should say. You have a region that is common to all 3 inequalities. That's what the simultaneous is talking about. All right. So this basically is saying when 2 or more linear inequalities are drawn simultaneously on a graph, their common solution, meaning the solution that satisfies all 2 or more, all right, lies in an area where the region representing the inequalities overlap. So remember, the inequality is represented by a region. We're talking about now 2 or more inequalities, and so it is where now the regions overlap. That is where you'll find a common solution. This area is called a common region, and is often in the shape of a polygon. In fact, always it will be in the shape of a polygon when we're talking about lines. All right. Now, this last part in red now is very important. It says the vertices of the polygon are especially important. The vertices. So what do we mean by the vertices? Meaning where the lines meet, right? So if you have 3 lines, and this is a common region between the 3 lines, then we're talking about these vertices here, 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 and here. Those vertices are particularly important because those vertices represent the points where the x and the y value, values that are valid in this common region. The points where the x and the y values have maximum or minimum, Therefore, if you want to find some function, some formula, like for example, you want to find profit equals 2x plus 6y, and you want to find out if you want to find out where the profit value, the P, is maximum, then you would go and use the values of one of these vertices. All right, remember, any point in the region can be used, any point in the region is valid. And if the lines are unbroken, any point on the line also are valid points. The lines are unbroken. All right, so when you want to find the maximum or the minimum value of P, you go to the vertices, because the vertices are where the X and Y values would be at their extreme in terms of either being at their maximum or being at their minimum. All right, and we're going to see questions where we use that. But I just want to point out now, if you want to find maximum or minimum of anything in a common region, you go to the vertices. If for any reason a vertex cannot be used, you go along a side. All right, and we see examples of those. So this, the red part, let me read it now. So the vertices of the polygon are especially important because they represent the points where expressions containing X and Y have maximum or minimum values. If the vertices cannot be used to find the maximum or minimum values, then the sides of the polygon are used. And we'll explain that as we go. There are instances where you cannot use a vertex. All right, there are instances where you cannot use a vertex. All right. So this is an example now. All right, and what we want to do is show the common region for those three inequalities, three linear inequalities. We want to show what the common region is. One common region. So we're talking about, this is one of the inequalities, this is the other one, and this is the third one. We want to draw all three of them on this one graph, and then we want to show the region that satisfies all three inequalities at the same time. One region that satisfies all three inequalities. That is called the common region. All right? And after we find that common region, we want to calculate, it says, and hence find the maximum and the minimum value of this expression, P. P equals 3x plus 4y. Right? I want to find what the maximum value of P can be and what the minimum value of P can be within that common region. All right? Within that common region. What's the maximum? And as I was saying, you go to the vertices to determine the maximum minimum. I'm going to do some examples and show you. All right, get some values. All right. So you want to draw these three inequalities. You want to draw the three inequalities individually, one at a time. This, then that. All right. That's what you want to do. All right. So look, I'm not going to go through the steps. I'm just going to say what each one is and show it on the graph. We spent a good bit of time yesterday on that. All right. So first one is the x plus y greater than or equal to 6. Now, if remember, the y on the left side is positive, so therefore the greater than means above. The equal is there as well, and so we need an unbroken line. And the unbroken line we're going to draw is the line x plus y equals 6, because that is the line that is associated with the inequality. All right, so see there, the y over here is positive, so the greater than means above. The equal is a part of the inequality right there. And so the line is drawn solid or unbroken. And then the line that we are drawing is the line associated with the inequality. So basically the same thing, except that you put the equal sign there. All right, that's a line associated with inequality. And what we are basically saying is that this inequality means above because of the greater than, unbroken line because the equal is there, and this is the line. So we have to draw this line, and we want the area above it. All right, but we're not going to shade it enough. Remember, we only want to shade the common region. So you don't put any shading over the graph, because we only want to shade the one common region. So that is the line x plus y equals 6. All right, and x plus, this I call this an x plus y line. I call this an x plus y line. I can just introduce that here right away. X plus y line. It will cross the y-axis at this number, which is 6, and also cross the x-axis at the same number, which is 6. So if it was at x plus y equals 10, then it will cross the y-axis at 10 and cross the x-axis at 10. That's how those lines go. X plus y equals 4. That line would pass here and here. We'll call them the x plus y lines. That will be the x plus y equals 4. So it's one of the easy lines to draw. And when we do linear programming, we're going to see a lot of these x plus y lines. I call them the x plus y lines. Easy to draw. Cross our x-axis and our y-axis at the same place, at the same value. And it's easy to see y as well, you know, because look at it. At this point up here, the x value is 0. So if this x value is 0, you see that the y is equal to 6. So the y is equal to 6. And then down here, the y value is equal to 0. And if you look back at it, x plus y equals 6. Down here, if the y value is equal to 0, x plus y equals 6. If the y value is equal to 0, then the x is now equal to the 6. So the x is equal to 6. All right, so that's the beauty of those lines, x plus y lines. Anyway, that is it. And what I do, I put an arrow. I don't want to shade it, but because I want above this line, I put an arrow down here pointing up. That green arrow there, I put an arrow pointing up. That is indicating that I want above that line. So the region that I want is somewhere up here. The region that I want is somewhere up there, but I don't shade it yet. Don't shade it yet. Don't shade it yet. Just leave the arrow down here, pointing up, to show that you really want somewhere above this line. All right, like that. The next line to draw is the line 2y greater than or equal to x. Or you need to show the line 2y equals x and the region above. So let's look at that one. All right. So the next one is 2y greater than or equal to x. So the y on the left side again is positive. You can see it. The y by here is positive. And so the greater than means above. The equal is there. And so the line is drawn unbroken. And the line that we're drawing is the one associated with the inequality, which is 2y equals x. All right. 2y equals x we're drawing. All right. So 2y equals x is this line. I'm not going to go through explaining why it is this line right now, but that is it. 2y equals x. If you put it in form, y equals mx plus c. All right, we can see it. If we write it as divide by the 2 and write y equals half x. If we write it as y equals half x, the same line. Y equals half x. And because there is no c, you see that it passed through the origin, and it has a gradient of a half, which is rise 1, run 2 to here. Then rise 1, run 2 to here. Then rise 1, run 2 to here. Then rise 1, run 2 to there. So you see that all those points are on the line. So you could get the line easily like that. All right? Nice and easy. I could plot 2 values. But in any case, that is a line. And then we want above this line. So I'm also putting an arrow pointing up, and you can see it down here. All right? Put an arrow pointing upwards. I want above this line. So right now, the region that we want is above this one and also above this one. So the region that I want is somewhere inside here now. You have to be above both lines. We don't want down here now, because that to be below this line. All right, so pay attention. The region that we want is somewhere up there. All right, so far that's the region we want. But as I said, we're not going to shade yet. I'll leave the shading until we put on all the lines. All right, so we're not going to shade yet. All right, so next line now is the y less than or equal to 4.5. That's the next one, y less than or equal to 4.5. So the y on the left side is positive, and so less than means below. Less than means below. So we can see that right here. The less than means below. The equal is there on the inequality. So the equal tells us that we want a solid unbroken line. And the line that we're drawing is a line y equals 4.5. Remember, y equals a number line are horizontal lines. Y equals a number line are horizontal lines. So y equals 4.5 is horizontal. So we're going to draw that one next. And so that is it. Pass through 4.5, and that is it you see on the diagram below. Y equals 4.5. And then this one below this line, and therefore we're not going to shade it. We're just going to put an arrow pointing down below this line. So one below that line. So if you look at it, if you look at all three now, since we have the 3 lines in place, we can start narrowing on the region that we want. So basically, if you look at those 3 arrows there, that's what we want, the region inside there. That region satisfies the 3 inequalities, right? It is above this line, which is what we wanted down here. it is above this one, which is what we wanted. And at the same time, it is below this one. So the region that we want is that triangle right there. And usually what they'll do, they'll ask you to shade the common region or the wanted region. Maybe once in the past they ask for you to shade the unwanted region, but most times they ask you to shade the common region, or they might ask you to put a letter, like put a letter S in the common region and stuff like that. All right, they have to follow instruction. But in any case, that's a common region, so we're gonna shade it. So what we're basically saying is that all points, what we're basically saying now, what we're basically saying now is that all the points in this region, all the points in this region, all of them, even the ones in the middle here, all the points in this region satisfy these three inequalities at the same time. So all points in that common region are valid under those three inequalities. All right, those points are your valid points. Points out here, out here, out here. These points out here now are not valid because these points are now violating one of those three inequalities, one or more of those inequalities. Not these points out here now are not satisfying those three inequalities simultaneously. So you cannot use any point outside here. Points outside here are now not valid. That is what is happening. You can only use points inside here. Another thing that is important is that you can also use points on the lines because the lines are drawn solid, unbroken. An unbroken line means that you can use points on the line as well. So not only are the points inside the green section there valid points, the points on the line are also valid. If let's say, for example, let's give a little example now and say something now. Let's say one of the lines was broken. So instead, let's say this one, for example, this one. Let's say this one was instead just y less than 4.5. Now what would happen is that that horizontal line, you have to draw it broken. Right? You still have this line solid down here, and you have still have that line solid up here. Right? Those three lines, those were your three lines. If it was y less than 4.5, and what that would mean is that points on this line, points are this on this, you could not use points on that line. Points on that line, you could not use them. Points on this line would not be valid. Not even the vertex right here will be valid because it would be on the broken line. Points on a broken line are not valid because then you would want values less than 4.5. Points on this line will be equal to 4.5, and you don't want equal, you want less than. So that's how the broken line can come into play, right? And we're going to do some questions later and see that. All right? But in this example that we have, all the points on the lines are valid, and also all the points inside the region are valid. Only points outside that region are not valid. And you will ask a question like that. You know? So for example, they might say, is the point 4 a valid point? So for example, right here, let me use the reading so you can see better. I might ask a question like, is the point 4 a valid point? 4, yes. 4 is a, mute the mic please. 4 is a good to go point because it is inside the region. But is the point 4.5 valid? 4.5. 4.5 would be right here. That's outside the region. So no, that's not valid. This one is not valid. This one is valid. So only points inside the region valid. Only points inside the region satisfy the three inequalities. All right. So they ask question like that. All right. So that is that graph. I'm just using this one as an example now. So the next part of it, having completed and shown the common region. It says show the common region. We have shown the common region by shading it, right? So that shaded region is what we call a common region. That's a common region right inside here. Common region. And we show it by shading. Now the next part now says hence find the maximum and the minimum value of P. Remember now, with this P that you want, the X and the Y value that you're going to use can only work inside this common region here or on the lines. You can't use the X and Y outside the common region to calculate P. Right? P cannot work outside it. No, P cannot work outside it. Right? And what they want is the maximum and the minimum. Now, look over this side now, why the vertex is important now. Watch this now. At this point, this vertex, the x value is 4 and the y value is 2. Right? X value is 4 and the y value is 2. Now, for an x value of 4, this is the lowest y value that you can use, in the command region. Because once you go in the region here now, you're getting y values now that are greater than 2. So this is the one extreme point. For an x value of 4, the lowest y value that they can have is 2. That satisfies the common region, satisfied all three inequalities, and that's why that is important. That point now is a vertex. It's one of the extremes. All right. If you look at this one out here, I think this point, I think I have them. So let me put them down. Right. So the vertices for the point are, so these are the vertices. I mark the vertices A, B, and C. So I call them A, B, and C, the three vertices. All right. So A is a point 4,2. A is a point 4,2. And as I was saying, for x value of 4, 2 is the lowest y value that they can have. Because if you come up here, this is 4,3. If you come up here, this is 4,4. If you come up here, this is 4,4.5. So the 4,2 is the lowest y value that they can get for an x value of 4. Right? And that is where you can calculate therefore your minimum, the minimum value of p. You're trying to find the extremes in it. You're trying to find where the x and y values are maximum or where the x and y values are minimum. That's at those occur at the vertices. B is 1.5, 4.5. Now look at this now. This is B now. 1.5, 4.5. Again, B is an extreme value because for a y value of 4.5, everywhere along this line, the y value is 4.5. Right? So for a y value of 4.5, what does that mean? Is that this one? Yes?
Sir, what did this extreme values again, sir?
The x and y values at the vertices are your extreme values. Let me show you. Let me see. Right. These are extreme values. Look here. In order to calculate a maximum or your minimum in this function, you want to use the extreme values of x and y in the region, for the region. Right? You want to use the largest x and y value that you can get to get the maximum, and you want to use the smallest x and y value that you can get for the minimum. That's where it's going on. Look at it. It's common sense, It's almost like common sense. If this is going to be its maximum, they need the x and the y to be maximum. You need the maximum values that those can be in the region. The maximum that x and y can be is actually right at this point, Because that's the largest x value and the largest y value on the region, right there. And the lowest that they can be, the lowest value that they can be, the lowest, if you want to calculate the minimum from these two, if you want to calculate the minimum is at this point, right? But then there's a little trick to it, because this point has a smaller x value. The x value right here is 1.5. And at this point, the x value is 4. So you cannot just look at one of them alone. You cannot just look at the x value alone. You have to look at the combination. And that's why you have to test the vertices to see which one will give you the minimum. Because whereas this one has a smaller x value than this one has a higher y value than this one. These two are the same y value, But this one, if you compare these two now, this one has a higher y value, but this one has a higher y value. Well, it has both of them, x and y. This one has a higher x and y value than this one. Higher x and y value than this one. But these two are the same y value, and this has a higher x value than that. At the end of the day, you must always test more than one point. And you'll always, I show you how you know which point you can eliminate based on the test you want to do as you go along. But let's continue. I want to calculate the value of P at each of the vertices to see which one is a maximum and which one is a minimum. So let's go again. So P, A is a point 4,2. A is a point 4,2. So what do I do to find the value of P there? Put the 4 and 2 in this formula. See it here? That's what we get right here. So it becomes 3 times the x value of 4 plus 4 times the y value of 2, and that works out to 20. 12 plus 8 is 20. Mute the mic, please. That's how we get the 20. So this is the p value at A. That's how we put the little A right here. The p value at A is 20. So at A, the p would work out to A. So if you're operating at A, where the x is 4 and the y is 2, the value of p at that point is going to be 20. All right? So if we come to the next one now, which is the B, this is right here now. B is this point now. Right here. All right? 1.5, 4.5. The x value is 1.5 and the y value is 4.5 at that point. Same thing again. P at B, because B is the point we're using. Plug the x and the y value in this formula again. So it becomes 3 times the x value of 1.5 and 4 times the y value of 4.5. That works out to be 21. So we see that this one is already lower than this one if we want to find minimum. And then now, clearly, it's almost like common sense. The C is where you're going to get your maximum, because C is where you have the highest x value and the highest y value. Right? So we can look at it. See there, C, the x value is 9 and the y value is 4.5. So the p value at C, you calculate it here. It's p value at C, you calculate it right there. Right? Using this formula. So the x value is 9, so it becomes 3 times 9 plus the y value is 4.5 is 4.5, and that works out to 45. And then all you're doing really is you're comparing these 3 values to get the maximum and the minimum. So clearly the maximum is 45, and you get the 45 maximum at the point C, and the minimum is 20, and you get the minimum at A. Now, if I choose a point in the middle, let's choose a point in the middle, you're gonna get it. So let me write it out. Let me write the solution first. So what we're basically saying is that the maximum is 45 and the minimum is 20. If I just randomly choose a point inside the region, right, it's gonna be higher than the 20 and less than the 45 if I work out P for another point inside the region. Because the 20 is the minimum and the 45 is the maximum. Let's say we choose a point inside here. Let's say we choose this point 4, 4. I want to work out the value of P at that point 4, 4. Let's call a point D. Then the P at D would be 3 times 4 plus 4 times 4. That's what it would be, you know, if you choose D. D is a point 4, 4 on the graph, which is inside the region. It's not going to give you the maximum there. It's not going to give you the minimum. The maximum minimum will always be at one of the vertices or along one of the sides where the x and y values are their extreme values, either extreme in terms of being small or extreme in terms of being large. All right? If we work this out, it becomes 12 plus 16. 12 and 16 is what? 12 and 16 is 28. So you see, it's neither minimum nor maximum. It's higher than the minimum and lower than the maximum. You understand? So the vertices are the points where you go to get your maximum and your minimum values. All right? And that's an example. And typically that's what you're going to be doing in linear programming. Now, just use these 3 to show you, but typically that's what you're going to be doing in your linear programming, which is what we're going to look at next. The only thing with the linear programming now is that they bring a business concept to it. And linear programming is a method that is actually used in businesses for real, in real life, right? Which is basically what we're going to look at next. Linear programming, right? Linear programming. So we're doing linear programming now, and it is used in businesses. It is used in businesses to determine maximum and minimum profit, right? And they usually use linear programming as part of business plans when they want to, for example, submit a plan to a bank to get a loan to start a business, for example, and you have to submit a business plan to the bank. All right, and sometimes you have linear programming is one of the methods now that you use to let the bank know what the maximum profit the business can make and what the minimum profit the business can make, and therefore the bank will know if they should give you the loan or not. It's something that is used in business. So this is what we're looking into now and looking at now. And it's a real life application of linear inequalities. What happens is that you use inequalities to represent limitations and constraints in a business. All right, I'm going to do an example and discuss some limitations and constraints. So you can relate to it. So let's read what is on the screen. It says this is used in businesses to determine maximum profit or minimum cost. That's what you always want to know. You want to know what your maximum profit is going to be, and you want to know what your minimum cost is going to be in a business. The process involves the use of linear inequalities to represent the limitations and the constraints of the business. When the inequalities that we use to represent the limitations and the constraints, when they are drawn on a graph, we get a common region. The common region is identified in the form of a polygon, as we just did a while ago. Whether it be a triangle, a quadrilateral, a pentagon, or whatever, depending on the number of lines. So if it's a 3 lines inequality, then you're going to get a triangle. If it's 4 inequalities you have, then you're going to get a quadrilateral. If it's 5 inequality that you have, then you're going to get a pentagon. Most times in 60, they don't tend to give more than 4 inequalities. They tend to give 3 on the regular, but if they go in, they tend to give no more than 4. All right, so you get a quadrilateral. Then now the vertices or the sides of the polygon are then used to find maximum profit or minimum cost. All right, so we could talk a little bit now and see if we can discuss it so that you can understand exactly what I mean by these limitations and constraints. I'm going to just use an example. Let me see if we can come up with an example now. So, all right, let's say you want to go into business. You want to start a little business. All right, and in the business, let's say you want to, let's say you're going into the business of motor vehicles, right? Motor, and let's say you want to do, let's say you're going into a business and you want to sell, you want to buy and sell cars. Mute your mic, please. Mute your mic. Cars and buses. Right? So you're going into the business and you want to sell cars and buses. All right. Now, there are limitations that you're going to have if you're going to sell cars and buses. What are some of the limitations you can have? One, the amount of money. Remember, you're going to buy the cars and buses in order to sell them back. You don't have an unlimited amount of money. So one of your limitations is the amount of money that you have. So based on the number, what they usually do is use, like, for example, X to represent the number of cars, Y to represent the number of buses. And so you're dealing with 2 variables. And so we're going to get some inequalities with X and Y in it, just as we did with linear inequalities. So one of your limitations might be that the total amount of money that you have to start the business is $10 million. Therefore, you say, okay, if I were to buy X cars and Y buses, I don't know how many cars you're actually going to buy now. I don't know how many buses you're actually going to buy now. But you know the cost of one bus. I know the cost of one car. So you can get an expression for the total amount of money that you spend to buy the cars and the buses, X cars and Y buses. And that total amount of money that you're going to spend will have to be less than or equal to the $10 million that you have. It's either going to spend all of the $10 million or you're going to spend some of the $10 million. In any case, the total amount of money that you spend will have to be less than or equal to 10 million. Right? Are they going to spend the whole 10 million? Are going to spend less than the 10 million? What is for certain is that you can't spend more than $10 million. So that's a limitation. So you represent that as an inequality. Total that you spend on the buses and the cars will have to be less than or equal to 10 million. And that is one inequality based on the money that you have. Another limitation that you might have is remember, you have to have a showroom for the buses and the cars that you buy. Right? Maybe it's a parking lot. You're gonna display the buses and the car in. You have to have somewhere to park them so people can come and have a look at them and stuff like that, like a showroom. So maybe what it is that the limitation that you have is that you can only park 20 vehicles. The parking lot you have can only accommodate 20 vehicles. So that's a limitation that you have. How would you represent that limitation as an inequality? The number of cars, which is X, plus the number of buses, which is y, would have to be less than or equal to 20, because you can hold only 20 or less. You can't be, you don't know that you're going to buy the full 20, right? But what you know is that the parking lot can hold 20 at most. 20 is the maximum. So total cars and the total buses will have to be less than or equal to 20. And so that will be another limitation, right? And you're right, represent that as an inequality. Another possible inequality that you can have, for example, is that you might be getting a deal from the people that you're buying. They might be giving you a deal, or they might be saying to you, okay, to get a good deal on the price, you must buy at least 10 buses. And you decide that I want that deal, and I'm not giving up that deal. You must buy at least 10 buses. What that means, the number of buses, which is y, will have to be at least 10, meaning greater than or equal to 10. That's another inequality, right? They might say to you, okay, in order for me, if I'm going to ship the vehicles, if I'm going to ship the vehicles within the next month, then the number of cars will have to be at least 5. Get another inequality, that x have to be at least 5, right? But then you might have another constraint, that the government might have some restrictions as to the number of cars that they can bring into the country in one shipment. But the government, so for example, you can't bring in more than 15 cars at any one time. Then the number of cars, which is x, will have to be less than or equal to 15. Stuff like that, right? So they usually give these limitations and constraints in sentences, right? You use words to describe these limitations and constraints. And the phrases that they use to describe these limitations and constraints are pretty regular. You know, almost is the same kind of phrase they use every time, right? And what I've done over here now on this side is to basically give you some examples of some of the phrases that they use and how we write the inequality based on those phrases. That is over on this side of the page now, and we're going to look at that. All right. And so that's how the process goes. When you do your limitations and constraints, you put them as inequalities. Then you put the inequalities in a graph. You get a common region. You get the common region on the graph, which is the shape of a polygon. And you want to find maximum anything, and they'll tell you the formula for profit. So you'll know how much you're selling the cars for, how much you're selling the bus for. And you know the profit. So the profit, maybe put the profit on a bus is $100. Just randomly on a car. So the profit on a car might be $100. Says 100 times X is the profit on all the cars. Plus the profit on the bus might be $200. It might be 200 times Y is the profit on the buses. So this is the total profit. And I might want it to tell them the maximum profit. So to find the maximum profit, now you go to one of the vertices of the common region, which we normally shade. All right. But the only thing left to do now is to actually do examples. All right. So what I'm going to do now is I'm going to look at some of the terminologies that they use. All right. I'm going to look at some of the terminologies that I use when they're doing these things. All right. Let me look at something else. So, yeah. All right. And then I'm going to show it on a graph. All right. So on the left side, are some of the terminologies that I use normally. Right. And on the right side is a graph that we get based on each statement. All right. Each of the statement. Now, for this example, what I did, I set up something that we can relate to. So I said, okay, let's say I'm starting a new class, and I want the class is going to consist of boys and girls. So there are students in a class consisting of boys and girls. So I don't know how many boys will be in the class, and I don't know how many girls will be in the class. But there are some conditions under which the boys and the girls now can be accepted to the class. There are some conditions in terms of the number of boys and the number of girls. So we're going to use X to represent the number of boys, and we're going to use Y to represent the number of girls. And that's how these questions always go. You always use some variable, some letter to represent the number of boys and the number of girls. And remember, guys, you don't know the X and you don't know the Y. All right. So X is representing the number of boys, and Y is representing the number of girls. And that's it. X is the number of boys, Y is the number of girls. You don't know X and you don't know Y. Remember, always you don't know X and you don't know Y. You don't know how many boys actually gonna have. You don't know how many girls you're actually gonna have. Because remember, the number of boys and girls now can be any combination in that common region. So you don't know exactly the number that you can have. You're just getting an idea of what combination is possible. All right, or what region you can get the number of boys and girls in that is possible. That's what this is right here. All right, so back over on the left side. So what are some of the terminologies they can use? So let's look at it now. The very first one here, that one. It said there must be a maximum of 30 boys. There must be a maximum of 30 boys. Think about it. Maximum number of boys is 30. It can't go over 30. So the number of boys, which is X, cannot be more than 30. It can be 30 or less. Another way of saying that is that there must be no more than 30 boys. That's the second statement. Saying the same thing. Means the same thing. There must be no more than 30 boys. Another way of saying the exact same thing is to say there must be at most 30 boys. At most 30 boys. In terms of the meaning, look here, in terms of the meaning that we're going to write as an inequality. The number of boys must be less than or equal to 30 in terms of an inequality. And then this is the inequality that you would write. X less than or equal to 30. That's the inequality. X less than or equal to 30 will be the statement for any one of these. Somebody have a question?
Mister, look, sir, is this what they would like give us in the exam? They would give us a table like this to fill out?
No. We're gonna look at some examples of how the questions are just now. I'm just getting you familiar with the terminologies. So what I'm doing now is just getting you familiar with the wordings that they use in the questions. All right, they can give you, listen, when you learn the thing in a boss, when you learn the thing, they can give you the question from all different angles, They can give you a graph and you have to get the inequality from the graph. They can give you the wording and you have to draw the graph. They can't give you any way. What you need to do is learn the concept through and through. Learn it from top to bottom, from front to back, from left to right. Learn it all around. Master it. That means it doesn't matter how they bring the question. So stop worrying about how they bring the question. When you learn the thing properly, it don't matter how they bring the question. You will know how to deal with it. Right? Mathematics is not just about how you solve questions. It's about understanding concepts and then you apply those concepts. And that's what CXC keeps saying. It keeps saying students trying to learn by rote and trying to learn that, okay, this is how you solve this question. And that's how you solve this question. So what they do? They change up the way they set the questions. And a lot of people get into problems. Don't worry about that. Worry about understanding the concept. When you understand the concept, then it won't matter how they set the question. So right now, I'm getting you to understand the terminology, get familiar with the wordings that I use in these questions on the regular. All right, and how you write the inequalities. I want you to understand these things. We're going to eventually get to the questions, Doing the questions is the last step. I could start by just jumping into the question, and just give you some question and say, this is how you solve it, No, I'm not doing that. I want you to understand every little thing, everything leading right up. I mean, when you get a question, you're applying all those base knowledge, the root, the foundation of the topic. I want you to understand the foundation of the topic. And then now you apply that foundation now to the question, regardless of how the question is set. You know how the question will be set. There have 1 million different ways of setting the question. You have to be prepared to answer the question regardless of how they set the question. All right, boss?
Yes, sir.
All right, good. So we could just focus and just stick with it. Stop worrying about the questions now. We're gonna do some examples and you're gonna see. Easy, you're gonna see that regardless of how they set the question, you'll be able to handle it if you understand these basics first. All right, that's what is important. I'm going step by step. So by the time we get to the question, we can challenge the question and apply everything that I'm talking about now to questions. All right. So that's the first one as an example. And as I said, this will be the inequality representing this information. And I can give any one of those three on the regular. Those are what they would normally say. One of those three they would normally say. And this will be the resulting inequality. And then now we know that this inequality in terms of what we put on a graph means below. Why does it mean below? So we're coming back to what we learned already now. It means below because of the less than. It means an unbroken line because the equal is there. And the line is the line x equals 30. The line is the line x equals 30. Right? X equals 30 is the line. So that's what this part is saying in terms of what you put on the graph. Below the unbroken line, x equals 30. And that's a vertical line. And if you look over on the graph over here now, see it here? This is x equals 30 line. And below x equals 30 means that you want to the left of that line. To the left of that line. You see that my shaded region is to the left. So what I'm showing you is a finished goods, the finished product. You would have to build it up from scratch, but I'm just showing you the finished goods, the finished graph over here. Right? We're going to learn how to build up this graph from scratch. And we're not going to have so many lines on it. I'm just using this as an example. But you see that my shaded region is actually now to the left of that shaded region, of the line. All right? So this is the line x equals 30 right here. And my region that I want is to the left of that line. Right there. All right, so that's the first one. All right, let's move to the second one now. Second one. So we've done this one already. First one, we've done this one. Let's mark it. Finish that one. The next one is that there must be a minimum of 10 boys. There must be a minimum of 10 boys. And let me tell you something before I even go any further. Plenty of people, for example, when they see the word maximum, they just feel like because it's maximum, they must use a greater than sign. See here? It's less than. Right? No, I always tell students, when you're in doubt about whether it's a max, is a less than or greater than sign they must use. Just think of money. Think of the same thing in terms of money. Because everybody understands money. Right? If you must have a maximum of $30, you need a maximum of $30 to do something. Maximum $30. It means that the number of dollars must be 30 or less. See, number of dollars must be 30 or less. Less than or equal to 30. We understand money. So when you're in doubt, just think of money. All right. So here now, they said there must be a minimum of 10. Now, plenty of people see the word minimum and just associate the word minimum with the less than sign, which is wrong. If you must have a minimum of 10, it means that 10 is the lowest. That's what it means, 10 is the lowest. It means that you want 10 or more. You must have a minimum of 10, means that you want 10 or more. Look at the next one. Look at the next one. So that's one. Next one says, there must be no less than 10. It means the same thing, no less. You can't go less than 10. It means 10 or more. You must be no less than 10. You go into a party, you can't go with, you go with no less than $10. It means you have to have 10 or more dollars. No less than $10. How much should I sweeted? How much of a sweeted? Boy, I'm not knowing about is no less than $10 for that sweeted. Means says 10 or more dollars for it. No less than 10. Look at the last one now, which is the one that they said the most. They mostly use these words, at least. That's the one that the most they use in exam question. There must be at least, I know I'm with this one. Plenty of people say the word least and associate it with the less than sign and forget about the true meaning of the word at least. If you're going to buy something, and I said to you, you're going to buy a biscuit, and I said to you, how much for it? And I said, my youth is at least $10 for that, At least $10. Somebody said that to you, it's at least $10 for that biscuit then. You know right away that is at 10 or more dollars for it, not less. So the number of dollars you need must be 10 or more dollars. At least 10 means 10 or more. Plenty of people make the mistake and use the less than sign to relate to the least. Don't do that. Use the true meaning of the statement. See the meaning here, so? The number of boys must be greater than or equal to 10. The number of boys, there must be at least 10 boys in the class. So the number of boys must be 10 or more boys in the class. See here? This is the inequality for that right here. So see there? That's the inequality. X, the number of boys, which is X, must be greater than or equal to 10. That's what that statement means. X is the number of boys, it must be greater than or equal to 10. And then in terms of the graph, what we put on the graph now, this is what we put on the graph. Above, because of the greater than sign. Above. Unbroken, because the equal is there. And the line that we're drawing is the line associated, which is the x equals 10 line. So that's a vertical line, x equals 10. and we're going to the right of that line. See it here on the graph over here now. See it here. This is the x equals 10 line. This vertical line passing through 10. And if you notice, my shaded region is to the right of that line because I want greater than, to the right of that line. And so I finish with the second one. Simple as that. Let's look at the third one. Talking about the girls now. I'm going to go into the girls now. It says there must be a maximum of 35 girls, meaning you can't have more than 35 girls. So right away, that statement here, this statement means that number of girls must be 35 or less. Remember, the number of girls is y. Y is representing number of girls. So number of girls must be less than or equal to 35, because 35 is the maximum you can have. Good? Another way of saying the same thing is that there must be no more than 35 girls. That's another way of saying the same thing. There must be no more than 35 girls. 35 or less girls they must have, not more. Not more. So the number of girls must be less than or equal to 35. Look at the last one. There must be at most, the most girls you can have is 35. The most you can have is 35. You can't have more than 35 girls. At most, that's another way of saying the same thing. So the number of girls must at most be 35, meaning 35 or less girls you must have in the class. So the class must have 35 or less. You can't have more than 35 girls in the class. So see this meaning of it here now. See it right here. The number of girls must be less than or equal to 35. Less than or equal to 35. Mathematically now, this is the inequality you would write for any one of these three statements. Y, which is the number of girls, less than or equal to 35. That is what you would write for your inequality, for those one in one of those three statements. Those three statements mean that inequality right there. And then now, in terms of putting it on the graph, what does it mean in terms of on the graph? The less than means below. See there? The equal is there, so we draw an unbroken line. And the line we're drawing is the line y equals 35. And the y equals 35 line is a horizontal line. Y equals 35 is a horizontal line through 35. If you look over on the graph here, so now, see it here? Y equals 35. And we're going below that line. Below that line. So, see there? My shaded region is below that line. See there? Below. That's that. Let's go to the next set now. The next set is that there must be a minimum of 10 girls. Minimum of 10. What that mean? What that mean? Minimum is 10. That means 10 or more. The number of girls must be 10 or more. The minimum, the lowest number of girls you must have is 10. Minimum meaning lowest. The lowest number of girls you must have is 10. So you can have 10 or more girls. So the class must have at least 10 girls in it, 10 or more. The minimum number of girls in the class must be 10. So it means they want to have 10, 11, 12, 13 or up. The minimum girls in the class must be 10. That's what the statement right here, so I mean this one. Another way of saying that is that there must be no less than 10 girls. No less than. People see the word less than. All right, the less than sign when in fact is a greater than sign you're supposed to have, because it said no less. No less. Right? So read the statement for what it really means. No less. These are the wordings that they use in the questions. You have to know the inequality that they mean. You have to be able to write the inequality. There must be no less than 10. It means they can have 10 or more. The one that they use the most is this one. This one, the third one, is the one that they use the most in CXC. There must be at least, I like to say at least, there must be at least 10 girls. If you must have at least $10 to buy the sweetie, it means that the sweetie is 10 or more dollars for it. So the number of dollars you must have is 10 or more. Right? There must be at least 10 girls in the class. At least 10 girls means 10 or more. That's what it means. 10, at least 10 girls means 10 or more girls. See the meaning here, so now? Right there. The number of girls must be greater than or equal to 10. The number of girls must be greater than or equal to 10. Why is the number of girls? And it must be greater than or equal to 10. All right, and you can see that right there. So this is the inequality for any one of these three statements over here. So any one of these three statements I give you, this is the inequality for it right here. And then now, how do we represent that on a graph? See here, the greater than, the whatever here is positive. So the greater than means above. See there, above. The line is unbroken because the equal is there. The equal is there, so we're going to draw an unbroken line. And the line that you're drawing is one associated with this inequality, which is the line y equals 10. And y equals 10 is a horizontal line passing through 10. Right? See it here? Horizontal line passing through 10 right here. Horizontal line passing through 10. That is the line. And you want above that line. So see, you want above that line. See it here? Above it. The region that you want is above that line. All right, that's it so far. All right, so let's go into some other thing now. Let's go into some other thing. Now, sometimes what they will do is use one word to represent the total. They use one word to represent the total of the two things. So, for example, if you're doing a farming question and you're doing apples and mangoes, the one word that will be used to represent the number of apples and the number of mangoes is fruits. You might say the total fruits in the basket is 10. That means that the number of apples and the number of mangoes in the basket must be 10. If they're doing vehicles, if they're doing buses and cars, as the example that we did a while ago, they might say the parking lot can hold a maximum of 20 vehicles. The vehicles now will be taken to mean the buses and the cars when you add them, vehicles, right? So they usually have words. If it's a farm and you're doing cows and horses, the one word to mean the total of the cows and the horses might be the word animal. Animals. So you might say, okay, the total animal at the farm can accommodate is 100. Means that the total number of cows and the total number of horses on the farm is 100. So in this example now, because I'm talking about boys and girls students, one word that is used to represent the boys and the girls together is the word students. Students. I have to look out for those words. Sometimes I remember there's a question where they spoke about phones and radios. And the word that they use for the phones and the radios were the word devices. The shelf space can hold a maximum of 10 devices, meaning the number of phones and the number of radios on the that the shelf can hold is 10. The word devices was used for the phones and the radio. So oftentimes with these questions, you have this one word that means the total of the two things that they're talking about. Now in this example, we are saying there must be at least 25 students in the class. The class must have at least 25 students in it, meaning the number of boys and the number of girls together must be 25 or more. The number of boys and girls together must be 25 or more. See it right here? What it means? The number of boys and girls together must be greater than or equal to 25. And see the inequality here, so now x plus y greater than or equal to 25. The x plus y is the total number of students. All right? X plus y is the total number of students greater than or equal to 25. All right? So when we
Sir, we can't hear you.
I think he's on a call.
yeah, sorry about that. All right. So So x plus y is to represent the total number of students. It must be greater than or equal to 25 because it's at least 25 students. Students is taken to mean the boys and the girls together. And what does this inequality mean in terms of putting it on a graph? In terms of what we're going to put on a graph. Remember, the y over here is positive, so the greater than means above. The equal is there as a part of the inequality, so we're going to draw a solid unbroken line. And the line that we're going to draw is the line x plus y equals 25. And I spoke to you about the x plus y lines. They're very easy to draw because those lines, see here, those lines, what happens with those lines is that they cross the x-axis at 25, that's the y-axis at 25, and they cross the x-axis at 25. They pass through 0, 25, and they pass through 25, 0. If you look over on the graph, see here, 25, 25, 25. That's the line there. X plus y equals 25. So the straight line passing through those 2 points, x plus y equals 25. An easy line to draw. And they like to give x plus y lines in these questions, you know, because they always give questions where they're talking about the sum of the 2 things that they're talking about. Always. So there's always an x plus y line in these questions for the most part. So that is that one right there. And then now we want above it, right? Above. So because we want above it now, the region is above that line. See here that I'm marking right now. The region is above that line as well. All right. And let's continue now. Let's continue. So now we come down to this one now. This one. It says there must be no more than 55 students in the class. That's the maximum number of students total. No more. The class can't hold more than 55 students. Right? 55 students. Students again is thing to mean the sum of the boys and the girls. So that's x plus y. X is the number of boys, y is the number of girls. So x plus y. Students is the x plus y. You said the number of boys and the number of girls together must be less than or equal to 55. You cannot have more than 55 students in the class. The inequality for that you're going to write is this one right here. The number of students, which is x plus y, has to be less than or equal to 55. That will be the inequality representing this statement right here. That inequality represents that statement. All right, and then how do we represent this inequality on the graph now? The y over here is positive, so less than means below. See there, below. The equal is a part of the inequality. The equal is there, so we're going to draw a solid unbroken line because the equal is there. And then now, the line that we're drawing is one associated with the inequality, which is x plus y equals 55. Another x plus y line. It passes through 0, 55 on the y-axis and 55, 0 on the x-axis. All right, so see it here, 55 on the y-axis, 55 on the x-axis. All right, and then you draw the line through that. That's it. And that's the line there, x plus y equals 55. And you always, if you notice, in all cases, in all examples that I have here, I label the lines with the equal sign. Look at it. Equal sign, equal sign, equal sign, equal sign, equal sign, equal sign. Always label the line with the equal sign because the line represents the equal mark. The line is the equal mark, and the region now is where you got, it takes the greater than or the less than into consideration. The region, the shaded region. But the line is the equal mark. So always label the line with the equal sign. Very important. Don't put any inequality on the line. So for example, don't label the line and put less than or equal to. Don't do that. Don't do that. Always label the line with the equal. The line is the equal mark. The line is the line. So label the line for what it is with the equal. All right. Let's look at this one now. So sometimes now they might put in a statement that they're describing an inequality straight for you. All right, straightforward. So look at this next one down here now. This one. It says the number of girls, which is y. Remember, the number of girls is y. Y is the number of girls. Number of girls, which we know is y, must be greater than, just greater than alone, you know, half the number of boys. That's half x. The number of boys is x. The number of girls, which is y, must be greater than half the number of girls. See here, number of girls is greater than half the number of boys. So sometimes they actually give you inequality that you can write it straight. See there, write it straight. So that one now equal in it. The number of girls, which is y, must be greater than half the number of boys. Now notice with this one now, the equal is not there. So the line is drawn broken. See that? The line is drawn broken. The number of boys must be greater than half the number of girls. So the line is drawn broken. We're using the above because of the greater than sign. And the y over here is positive. So greater than means above. All right. And then now, what we said, because the equal is not there, we want a broken line. So that's the only one where the equal is not there. So that's the only broken line. And then the line we're drawing is the one associated with this inequality, which is the line y equals half x. And for y equals half x, we can either use the rise over run for the half. And remember, if it's y equals half x, there's no c. So it passed through the origin, right? Pass through the origin. See there? Pass through the origin on this side. And then no, it's gradient is a half. The gradient is a half. So it's like a rise 1, run 2. So look at it there. So rise 10, run 20. Get to that. Rise 10 more, run 20. Where is it? Yeah, run 20. You get to this. Rise 10 more, run 20. You get to that. Right? Because remember, half is the same as 10 over 20. So you can rise 10, run 20. Or you can just plot 2 points. Right? You can just plot 2 points. So you plot 1 point, which is 0, 0 here, because 0, 0 is on the line. And then put another point where the x value is 60. If the x value is 60, then half of 60 is equal to 30. So the y value is 30. So it passes through a point 60, 30, which is 60, 30 is right here. Right here, 60, 30. So it passed through 0, 0, and it passed through 60, 30. And then you draw that line. You draw it broken. What does that broken line mean? It means that I want above it. We also want above it, right? Above it. So above this line as well. Let's mark it above this line. So the broken line, zoom in on this graph now. So those are my inequalities so far, right? And that's my shaded region. So you see that this region that I've shaded satisfy all the inequalities. It satisfies the region satisfies all the inequalities. So basically that's my common region. All right. And again, for this one, I label the line with the equal sign. Y equals half x is that line. And I draw it broken because the equal is not there. So, all right. So by drawing it broken, I know that the equal is not there. I know that the equal is not there. All right. So what that means now? That means that points on this line are not valid. Right? So if I zoom up this a little bit, no, I can't zoom it up anymore. I'll lock it. Yeah. What it means is that the points along here, are not valid points. All those points are not valid. You can't use any point, then mark them in red. You cannot use any of those points on the graph because they are on the broken line. Right? So these points cannot be used. You can't use any one of these points. Any point along this piece cannot be used. You can't even use this vertex and you can't use that vertex. Those points are not valid. So number of boys and girls that you have cannot be on this line, any part of this line, number of boys and girls. So for example, let's look at an example now. For example, let me show you an example now. This point right here is 20 boys, X is number of boys, right? 20 boys and 10 girls. Can't have that because it's on the broken line. And by saying no, it said the number of girls must be greater than half the number of boys. The number of girls must be greater than. Right now, the number of boys, the number of girls, the number of boys, the number of, hold on, X and Y, right? The number of girls is just equal to half the number of boys. And them say it must be greater than. And that's why this point here cannot be used. Right? That point cannot be used. Right? This point also cannot be used right here. Where we have 15. We have 15 boys, and that will be like 15 boys and 7.5 girls. You can't have 7.5 girls anyway. But right here, for example, now also cannot be used. 30 boys. 30 boys and 15. 30 boys and 15 girls right here. Cannot be used because it's on the broken line. Points on the broken line cannot be used. Now, when the point on a broken line cannot be used, that is when we say no, you go along the side. Right? So if you have to use this vertex, if you're considering that vertex for something, because you cannot use it, it's on the broken line. You have to go along this side and use a point on this side, somewhere along here. You have to go along here and use a point on this side that they can use. But all the C6 require you to do that. Most times these days, they give a question, we can actually use a vertex. All right. Now let's get into the maximum or minimum now. So now that we have the shaded region, right, it means that you can operate number of boys and girls anywhere inside here. So for example, as I said, you cannot have this. You cannot have this point. This point is not valid right here. We have 15 boys and 10 girls. It is outside the region. Can't use that point. This point is not a valid point. It's outside the region. You can use points inside the region. So, for example, I can use this point right here. So I can have 15 boys, and the x is 15, and the y is 20. So I can have 15 boys and 20 girls. That is good. That is a valid point. It's inside the region. Right? I can operate here so as well. That is 50. That's not 15. This was 25. Sorry, 25. 25 boys and 20 girls right here. 25 boys and 20 girls. Right here is 15. 15. So right here is 15 boys and 25 girls. That's good. You can operate there. Class can operate with that number of boys and girls. All right. So you can have any combination of boys and girls inside the region there, and you'll be satisfying the condition, just that you cannot use any along this side. That's a broken line. You cannot use any along that side. All right. Well, let us go further now and look at how we can do some of the calculations now. All right. Let's look at how we can do some of the calculations. How the calculations come into play for to get maximum and minimum. And we're looking at an example, So this question says, the amount paid, right, by the students is given by the formula 30x plus 20y. So what that means is that what this statement means is that the boys paid $30 each. Let's say it's money. Oh, it said it here. Sorry, it said it right here. It's placed right there. It says each boy pays $30. So it's $30 for each boy. And each girl pays $20. And the total amount paid is P. So you want to write a formula. 6, you like to ask you to do that. Write a formula for the amount paid. This should be a formula for the amount paid. Because each boy, one boy, paid $30. And it's X boys you have. So the total amount paid by the boys is this, 30x. And then each girl, one girl, paid $20. And it's Y girls you have. And therefore, the total amount paid by the girls is 20 times Y. $20 times Y girls. And so the total amount paid by all the students, is this. This is total amount paid by all the students. Because we're using P dollars. So we have to put a dollar sign in there. Right? P is the amount paid by all the students. I don't know that we're working in dollars. And then the question now is saying, determine the maximum amount paid by the students. All right, so look at this now. Now remember, the maximum amount paid is going to be at one of the vertices. Right? Here, or here. Remember that this vertex out of it and this vertex out of it, because they're on the broken line. I can't use any of those two vertices because they're on the broken line. So it's one of those two. But you can actually reason it out. Right? Now clearly, look at it now. You don't have to actually test all the points, if you want the maximum. You're looking for the points where the number of boys and the number of girls will be the highest or higher than the other points. Now clearly, A has more boys than here. So if you consider maximum, you don't need to consider this point, because A already gonna give you more higher profit or a higher amount paid than this point. Also, if you notice down here, the values number of boys and girls down here low. You don't have to go there. So those out of it when you want to calculate the maximum. So you're getting the maximum either at this point or at this point. Now, why we have to test both of them? Let me explain to you why I have to test both of them. Because whereas this one has more girls, this one has more boys. Right? This one has more boys. So this one has more girls, but this one has more boys. if you look at it. Because this one, the Y value is higher on this one, but the X value is higher on this one. So you cannot look and know. So what you have to do, you have to put the two of them, test both of them in the formula for the profit over here. So you calculate what not the profit, the amount paid. You calculate what the amount paid would be at A, and calculate what the amount paid would be at B. So you see it over here, so now A is a point 2035. You can see it. A is a point, it's here, 2035. That's the point A, 2035. And B, let's look at B. B is a point 3025. See there? B is a point 3025. And then, so what this means is that you have 20 boys and 35 girls at this point. And at this point, you have 30 boys and 25 girls. And to see which one of them going to give it a higher amount paid, you test them in the formula right here, test them in this formula. So this one is the one at A. See the 20 there, 20 come here, and the 35 go there in this formula. And that works out to 1300. That's the amount of money if you use 20 boys and 30 girls. And then for B now, which is this one, using this number of boys here and this number of girls here in this formula, in the formula for the P, the X and the Y, that works out to 1400. Now, clearly 1400 is higher than 1300. So therefore you can conclude this. The maximum amount paid is $1,400. And put in the dollar sign. $1,400. This was just like a test to see which one it is. This was just like a test. You're testing the 2 points to see which one come out higher. And it confirms that the B. So if you want to get that maximum amount paid, you're gonna operate that B where you have 30 boys. See there, 30 boys and 25 girls at B. That will be the number of students in the class where to get the maximum amount paid if you operate right at the vertex B. Now, if you're going to go for the minimum amount paid, if you want the minimum amount paid, this is still a formula for the amount paid up here. You know? If you want the minimum amount paid, then you want where you have the minimum number of boys and girls in the class. And that is at one of these 2 points. You don't, in a sense, we use this one because this point down here will have less girls than this point up here already. So it must give you a low amount paid. So it don't make sense to waste time and consider that point up there. We take it out. And then now, why we have to use this point? Same reasoning. Where this one has a greater value of Y, greater number of girls, this one has a greater number of boys, X. So you have to analyze the two of them, test both of them to see which one come out to give it the lowest. Which of them is the lowest amount paid. Right? So let's look at it again now. Right? So one is T and one is S. So T is 10, 15. See there? T is a point 10, 15. See there? T is a point 10, 15 right there. And then S now. S right here is a point 15, 15 boys, 10 girls. See there? 15 boys, 10 girls. Notice this add up to 25 and this add up to 25 too. 25 students. Remember they're on this line with total is 25 now. Right? These two are on the total line with total is 55 up here. And up here, this add up to 55 students, this add up to 55 students. I want to know which combination going to give you the most the maximum amount paid. Right? So you come back down here now. So what you do? Put them in the profit up here again. Put them in the profit formula up here again. See there? So at T, this one is at T. You put the 10 and the 15 for the X and the Y in this formula. And that works out to be 600. So the amount paid, if you operate at T, where you have 10 boys and 15 girls, you're getting $600. But if you operate at S, you have 15 boys and you have 10 girls. Put them again in this formula right here. Right? You're putting them in the formula. That formula telling you the amount paid. So you put the number of boys and girls in that formula. And that tells you that they're going to get 650 at S. So which one of them is lower? The minimum. The minimum is clearly this one right here, T. So the minimum amount you're going to get from operating the class is 600 when you have 10 boys and 15 girls. See here, the minimum amount paid is $600 when there are 10 boys and 15 girls in the class. That's a typical example. All right, so far so good. But all right, I've been talking a lot for a while. But all right.
Yes, sir.
Yes, sir.
All right. All right. So what we're gonna do now? Good. What we're gonna do now? We're gonna look at some real questions now. A couple of real questions. No, it's no. Let us go for another hour or so and do a couple of questions. All right. We'll try and do at least 2 questions before the day, and then Wednesday start the class on Wednesday with a couple more questions. I do some questions on Wednesday, and then I give you one to do for yourself. All right. So that's all explanation, guys. We are finished. We're ready for the questions now. All right, we're ready for the questions now. So let me go and find the questions, right? All I need to do now is find the questions. All right, let me see where the questions are. All right. Let's see where the questions are. So the questions here somewhere. I'm going to use this for my graph. All right, wait first. These are my questions. I know I need these. I need these questions, right? So we're gonna be doing these questions. I'm gonna jump under the very first one now. Under the first one right there. Everybody can see it under that one, first one. Everybody can see it still? Let me see. Let's do it like this. Yeah, let's do it like that. And get no more. All right, so I'll do that question. All right, and then I'm gonna need somewhere to do it on, something to do it on, right? All right, let's gonna do it. I'm gonna do it. Let's close this. We don't need that anymore. I don't need this anymore. And we don't need this anymore. Still need that. We want to need this. What I need now is something to write on. Good. So I'm gonna write on that. All right, we're gonna be writing on that. All right. Boom, bang. All right. So we basically want to do this question now, and then I'm gonna float this, and I want to draw the graph. All right. So let's look at this question now. All right. Everybody can see it. Everybody can see the question. This one over here, you're doing this one. I'm doing this question right here. So exam past paper from 2009. Trust me, this question get easier and easier as the years go by, right? So you don't have to worry yourself. They're getting easier and easier. So the ones that they're setting in recent times are much easier than the ones that they set back then. So if you can do these older ones, believe me, you'll be able to do the ones that they're setting in exams these days. The quicker, easier, shorter. But I like to teach you the more structured ones. All right, the old time ones are much better to learn from. All right, let's go. I'm going to reason out this one now. Pay attention. Anything you don't understand, tell me. It says the owner of a shop wishes to buy X guitars and Y violins. Now, X is the number of guitars, Y is the number of violins. Always remember, you don't know X and you don't know Y. So they're buying X guitars. Let's write it down. X guitars. And they're buying Y violins. You don't know X and you don't know Y. So what they're gonna do now, they're gonna tell us the conditions under which they buy the violins and the guitars. All right. It says to satisfy the demands of its customers, the number of violins must be less than or equal to the number of guitars. Remember, the number of violins is Y now. What did they say? The number of violins, which is Y, must be less than or equal to the number of guitars, which is X. See that? So simply put that statement, and I will always tell you to write inequality for the information. See it here? Write inequality for the information. So part 1, we have to write that inequality. Y, which is number of violins, is less than or equal to the number of guitars, which is X. Simple as that. Done. 3 marks. But understand that? That's the first inequality right there. But to go to that, and we're going to have to draw this on a graph. Soon we're going to have to represent it on a graph. So far, so good? So far, so good. All right. Look at the next statement now. The cost of one guitar. So let's put the information up here. Telling us about the cost now. All right, let's put it up here. Let's put it in red. So in terms of cost, the cost of one guitar is $150. So this is a $150 each. $150 for one each. That means $150 for one, you know. Remember, it's X guitars, you know. $150 each is the cost. And the violins is $300. $300 each. $300 for each. Meaning for one. And it's Y violins I have. All right. It says he has $4,500 to spend on the purchase of the instruments. Let's think about it now. So he goes to the store to buy the violins and the guitars. Remember, you don't know much violins, you don't know how many violins he's buying, how many guitars he's buying. You know. All you know that he's gonna buy X guitars and Y violins. And he's paying $150 for each of the guitars. And he's paying $30 for each of the violins. And he has $4,500 in his pocket to spend. Somebody tell me now what is the limitation? We're gonna write an inequality now for that information. He only has $4,500 to spend.
Sir,
somebody tell me.
The maximum 4,500 can be less than.
All right, you're on the right track. I'm gonna clean it up for you. Good, like that. So the maximum he spend is 4,500. So what you need is an expression for the amount that he actually spends. So the amount that he spends, so see here, look at it. The amount spent, see here, let's look at it. You need an expression for the amount that he spends. So the amount spent has to be less than or equal to the amount that he has, 4,500. We're not going to put the dollar sign. We don't need to put the dollar sign. All right? The amount spent is less than or equal to 500. So we need to write an expression for the amount spent and put it less than or equal to the 4,500. Remember now, you know, he's spending $150 on each guitar, but he's buying X guitars. So somebody tell me now, what's the total amount of money that he spends on the X guitars?
X times 150.
Good. X times 150. But just write it nice and write 150X. Plus he spends some money on the guitars. He's spending $300 on each guitar, and he has violins, right? He spent $200 on each violin, and he has Y violins to buy. So what's the total amount of money that he's spending on the violins?
300 Y.
Good. 300 Y. 300 Y. Good. So that's the amount of money that he spent. This is the total amount that he spends, you know. He spent 150X for all the guitars, and he spent 300 Y for all the violins. And that total amount that he's spending has to be less than or equal to the amount that he has in his pocket. That's your inequality. Well, guess what now? This inequality can be simplified, don't it? Because all these numbers are multiples of 150. See that? So divide it down. Divide it by 150 and simplify it down to the lowest terms. So I'm going to divide by 150, simplify it. So you divide by 150, your inequality becomes X plus 2Y less than or equal to what is now 30. That's your second inequality. So far, so good? That's a second inequality right there. I remember, you know, we're going to have to draw this on a graph. We're going to have to draw this on a graph, right? But let's write the inequalities first. And then we'll deal with that part afterwards. Third thing now. It says, see it here now? Right here now. something else. To get a good bargain, from the store, the owner of a shop must buy at least 5 violins. So like him go to the store and I said to him, if you buy at least 5 violins, I'll give you a long time to pay. I'll give you a discount. To get a good bargain, he must buy at least 5 violins. What does that mean? At least 5 violins. What does that mean? Third condition. Remember, violins. Violins is wine.
5 violin.
At least 5. No man, let's think of money, man. If you must have you must have at least $5 to buy something. What that means?
5 or more.
More or more, yes,
Exactly.
sir.
Exactly. I always think of it as money. I know we're just getting into it, so I don't know have it fully yet. You're going to get it fully now, soon. So the number of violins that he's buying, which is Y, has to be greater than or equal to 5, at least 5. That's it, This is the number of violins has to be greater than or equal to 5. That's what this statement means. You must buy at least 5. Number of violins must be 5 or more. That's the inequality for the third one. That's the third one. So that's the answer for the third answer there. That's it, teacher. That's it. Yes, and that statement. But it's good so far?
Yes,
So far, so good? All right.
Yes, sir.
All right. Yes? So this is just part A. Yes? Question? But all right. All right, good. Then we jump into part B now. See it here? Part B now. So we have the 3 inequalities now. Part B now is telling us to draw the graph. It says using a scale of 2 centimeters on the horizontal axis to represent 5 guitars and 2 centimeters on the vertical axis to represent 5 violins, draw the graph of the lines associated with the 3 inequalities. So we're going to have to go now and say, all right, what this mean in terms of the graph, and what this mean in terms of the graph, and what this mean in terms of the graph, and then draw those 3 lines. And then after we draw the lines, we have to shade the region that satisfies the 3 inequalities, which is what we call this common region. And so the question helping us here. Next thing I want us to do is state the coordinates of the vertices. Remember we spoke about the vertices being those important points. So question helping us along the way. These are the things that must always do. State the coordinates of the vertices. So we want to state the coordinates of the vertices. And then after we do that, then they're going to tell us now about some profit thing. And we have to calculate the maximum profit. This is a full question. All right. But all right. So already know we're going to do the graph part first. But to do the graph, we need to know what each inequality, how would represent each inequality on the graph. So let's do that in red. Let's do that in red. Right beside it. So for this one first, I'm going to put this one in red. I'll put it in blue. Let's put them in blue. Right. So I'm going to put what this one means on the graph. I'm going to put what this one means on the graph. I'm going to put what this one means on the graph. We're going to put it simple. Now remember, the keywords are above or below, a broken or unbroken line, and then what the line is. That's what we're looking at. So let's do the first one. So tell me now, we want above for the first one, this one. We want above or below a line for the first one. Remember, inequality on a graph is either being above or below a line. So put in now how we're going to represent this on a graph, how we're going to represent this on a graph, and how we're going to represent this on a graph. Talk to me now. The first one right here.
First one is
What do we say?
below.
Below. Good. Whatever here is positive, so less than means below. All right. We're just putting in the keywords in us. So we're going below. We're going to go below this line. The line is going to be broken or unbroken.
Unbroken.
Broken.
Oh, the equal is there. The equal is there, so it's an unbroken line. If you want to write the word solid, you can write solid too, you know. So it's going to be an unbroken, solid line. Unbroken. Unbroken. Or solid. If you want to use the word solid, you can use the word solid. It's going to be a solid line. And which line are we going to draw? Which line? What's the equation of the line we're going to draw? What's going to be the equation of the line that we're drawing? What is the line associated with this inequality? I'm going to tell you, it is just y equals x. Replace this with the equal sign. So the line that's associated, with this inequality is a line y equals x. Simple as that. It's not complicated. So we're gonna draw this line, we're gonna draw it broken, and we're gonna mark the region below it for that one. Let's do the next one, this one. Let's do that one now. Ready again. Above or below, whatever here is positive. Notice first, whatever here is positive, whatever less than the sign. Below, going below this line. Very good. Below. Yeah, first thing is below. The equal is there, so we need an unbroken line. It means that the line is valid, right? So we need an unbroken line. Unbroken. So let's start get it now. You know. Unbroken. And then which line are we drawing? What's the equation of line that we're gonna draw?
X plus 2y equals 30.
X plus 2y equals 30. Now watch me now. You see this line easy for drawing now. This line pass through points like 0, 0, and it pass through like 60, 60. 60, 60. To 60, 60. Pass through them points there. Easy. Pass 2 points where the x and the y value is the same. So that's easy for draw. This line now, we're going to find 2 points on it that we're going to need. Because we're going to need to plot 2 points on it. How did I show you to plot 2 points on this line quickly the other day? I showed you yesterday. How can we do it quickly? 2 points on this line. Mute your mic, please. Oh, no, don't mute your mic. All right. Tell me, we're going to get 2 points on this line quickly. I showed it yesterday. 2 points. We want 2 points on this line quickly to draw that line. What we're going to use. All right, let me show you again. Remember, we put on 2 points. Yeah, say what you're saying. Say it.
I was going to say that you locate your x and y, or all right, go ahead, sir.
No, that's that other one. Remember to draw that line quickly. No, man. To draw that line quickly. Want to do it quickly now. You go put on 2 points where one of them the x value is 0 and the other one the y value is 0. And then you just use the line to get it. Now look at this one. Look at this now. When the x value is 0, look at this quickly. What would the y value be? Let's look at it quickly. Easy. Easy. I'm write it down again.
So 30.
X. Look, no. Wait, no. X plus 2y equals 30. So if the x value is 0, then this becomes 0. So if the x value is 0, what is the y value? This is what you have left if the x value is 0 now. What will be the y value? If 2y equals 30, what is the y value?
15.
15. That's how quickly you can get it. 15. This is 15. And for this one now, when the y value is 0, this becomes 0. What is the x value equal to? What's the x value equal to? The y value is 0.
30.
Yeah, man, x value equals 30 right there. So 30. 30. You know, overthink it, you know. Let me do it again. Look. You have x plus 2y equals 30. You want to get 2 points to put on that line quickly. One of them may give it an x value of 0. This one is on the y-axis, you know. This one is going to be on the y-axis. And then I want to give it a y value of 0. This one is going to be on the x-axis. I showed you yesterday. No problem. Showing you again. All right. All you have to do for this one now, you say, okay, just imagine say this as 0. That as 0, this is what I have left. 2y equals 30. And if 2y equals 30, divided by the 2 is instead of y equals 15. As easy as that. Right? As easy as that. And then for the other point now, when the y value is 0, this is going to become 0. And so the x is going to be 30. When the y is 0, the x is 30. So those are 2 points on the line quickly. Quick like that. All right, no problem. I'm going to do it again multiple times. I'll see it again multiple times. But that is what we do. So this one is going to be on the y-axis. Because the x value is 0 on the y-axis. And this one is going to be on the x-axis. This one is going to be on the x-axis. All right. This last one now. Ready now? Talk to me. Above or below? This one we're doing now. This one. Above. Whatever here is positive, greater than means above. Very good. So this one is above. And then now, broken or unbroken?
Unbroken.
Unbroken.
Good. Unbroken. Very good. I'm gonna draw solid lines. So none of the lines broken in this, right? And which line are we drawing? Which line are we drawing?
Y equals 5.
Very good. Y equals 5. Now remember, the Y equal number lines are all horizontal lines, right? It's a horizontal line passing through 5. X equals a number line, like X equals 6, will be a vertical line. So let's put the horizontal like this to remind me that is a horizontal line. Just remember, Y equals a number are horizontal lines. Because remember, the x-axis is actually Y equals 0. So Y equals a number is always horizontal like the x-axis. All right, you're going through, no problem. You'll remember, then we'll do more and more examples. So we're going to draw a horizontal line. So we have the information we need now for the graph. So all we need to do now is actually draw the graph. So make us see how we can set this up now. So we can draw the graph. Let me see now. Watch this now. Let's try it in. Let's try it in. Let's go again. All right. So I'm supposed to be able to float this. No, not working. Oh, let's give me a second, guys. Just give me a second. I want to be able to show all the information. I want to be able to show all the information that we're going to do. Not working. I can't get it to work. All right, let's use these two. We can come back. We can come back to the thing afterwards. I'm not getting it to work how I want it to work. All right. All right. See there now. All right, it's floating now. I want it to float, and then I want to get back the graph. I want to get back the graph. I want us to get back this graph. So I'm trying to put in. I'm trying to put on this graph. Lord. Giving me a fight. Let's see. I want to put on that graph right there. All right, let's see if we can do that. Do that. Do that. All right, let's do it this way. We can always come back to the question. We're gonna do the graph now. I was trying to keep everything on the screen, but it's not. It's giving me a fight here. All right, let's see if we can get. All right, good. All right, so I'm trying to represent those three things now. Those three lines on this graph, right? Those three lines. I want to draw them on this graph here now. All right, so let's pin this. Let's pin that. All right. All right, so I'm trying to get this. I'm trying to get these graphs, these three lines on this graph now, right? So basically, I started a little thing. Now, what scale did the question tell us to use again? Oh Lord, I don't remember the scale. What scale did it tell us? It said 2 centimeters. It said 2 centimeters to, let's go back at the question. It said 2 centimeters to 5 units. That's what it said on the x-axis, and 2 centimeters to 5 units on the y-axis. All right, 2 centimeters to 5 on the x-axis and 2 centimeters to 5 on the y-axis. So let's go and do that then. So I'm gonna put it here. Oh boy, just giving me problems. Let's bear with me a little bit with this, right? I'm kind of experimenting. All right, 2 centimeters to 5. So it means that this is going to be 5 right here. It's going to be 10. That's going to be 15. That's going to be 20. That's going to be 25. That's going to be 30. That's going to be 35. Hope everything can fit in now. 35. All right, and up here is the same thing. It's gonna be 5 right here. It's gonna be 10. I'm scaling up the graph. 15, 20, 25, 30, 35. All right, so we had use 0.60. So we can use 0.60 on this again. We're gonna use 30, 30. So we're gonna use 30, 30, which is a point on this line anyway. All right, 30, 30, 30, 30. That's what they gave us that scale. All right. So we're gonna draw the lines now. So I have a line on it already. All right, so I'm going to use that as one of my lines. So the first line, remember, is the line y equals x. And then y equals x pass through 0, 0. So I'm going to position this line 0, 0, which is right here. And it also passes through 30, 30. So I'm going to move this into 30, 30, which is right there. But can see that?
Yes. Yes,
So
sir.
that will be a first line. That will be a first line. And what did we say? Label the line with the equal sign. Let me use the same color. Let's use this same color right here. All right, label the line with the equal sign. So this line is the line y equals x. Label the line with the equal sign. And then we want above or below that line. We want below. So put the arrow pointing down to show that you actually want below this line. That's the first one. But good? That's the first one. All right, and I'm going to do another line. All right, I'm actually going to copy this line and I'm going to it's not working. All right, that's not working. So let me get another line. I'm going to draw another line. So I can get another line from here. All right, so the second one I'm going to draw now. The second line, see here, the second one. So this is the second one. All right, so the second one, remember, I passed through, the second one passed through 0, 15, remember? 0, 15. So I'm going to put 1 point at 0, 15 right there. And the other point is going to go to 30, 0. So I'm going to move the other point down to 30, 0, which is right there. That's the second line, you know, but I'm going to also extend it. So I can label it like that. That's my second line. But understand that? Let's see if we can change something, change the style, make it a little bit thicker. All right, that's my second line. All right, that's my second line. So those are my 2 lines so far. Let's make this one a little thicker too. All right, I'm not getting to make it, but always label the line with the equal sign. So this line now I'm going to write it as x. I'm going to write this line now as x plus 2y equals 30. That's my second line. And I want above that line, not it? No, I want below that line. Below, no, above. The second line right here is below. See it here? Below. Below. So I put arrow pointing down on this one as well. Arrow pointing down. What that means that the region that I want is somewhere under here so far, but I don't finish it. I have to put in the third line. All right? So I don't finish it. So let me delete those shadings. Let me delete those. I'm going to put in the third line now, which is this one. Y equals 5. Actually, y equals 5, this one. So y equals 5 now is going to be a horizontal line passing through 5. So let me go for a horizontal line now. Horizontal line passing through 5. So I need a horizontal line. See here, horizontal line passing through 5. See here? That's my next line. Right there. I'm going to stretch it out here. That's my next line. I'll make it a little thicker. You can see it. So that's my next line. And what did we say? Label the line with equal sign. So this line now is y equals 5. Y equals 5 is the next line, right there. And put our arrow pointing up. So far, so good. So you see, therefore, that the region that we want is actually now in that triangle right there. This triangle is above this line, below this line, and below this line. So the region that I want for this inequality is right inside that triangle there. So that is where we shade. Remember the second part of the question was for us to shade it. So we're going to shade that region. Use a different color for the shading. We're going to shade it. Let's shade it in green. We're going to shade that region now. See here, shade it. So shade it. Shade the common region. That is a common region. That is a region that I want. Let me see if we can zoom it up. Take it. All right. Good. So that's our region right there now that we're working with. But you can see that good. That's our common region. And the next part of the question then was for us to, after we shade it, question said we were to write the coordinates of the vertices. I said that? Write the coordinates of the vertices. I'm going to give each vertex a name. So you don't just write the coordinates, you give them a name so you can reference them. Right? So let's go for the pen. I'm going to use a different color. Let's go back for the blue. Let's go back for the blue for what we're writing. All right, let's go back for the blue. Which blue? This one. All right. So we're going to call this one A. A. And that point A is going to be 5, 5. Good? 5, 5. And then this one, we're going to call this one B. B. And B clearly is 10, 10. 10, 10. What I get that? B is 10, 10. And then this one now, we're going to call it C. And it's actually right here now. It's actually right there. C is right there, which is 25. This point, we're going to call it C. And that point is 25. 5. So far, so good. And the question asks us to write down the vertices. So let's come back over here now. We're doing part B. We're doing part B of the question. And part B, we had the lines. We had to draw the lines. For part 1 B was to draw the lines. Part 2 was the shading. Shade the common region, don't it? And part 3 was the vertices. The vertices. Vertices of the region. And the vertices of the region, we can write them down now. A is 5, 5. B, that our vertex is 10, 10. And C, let's write it here. C, the next one is 25. 25. So what does that mean? The 5, 5 means you have 5 guitars and 5 violins. And the B, you have 10 guitars and 10 violins. And C, you have 20 guitars and 5 violins. That's what that means. All right. Now, the next part of the question now asks us for some additional stuff, right? Let's see if we can find what the question said. I was hoping that I could float the question on top, but it's not working out for me today. I tried it earlier and it's just not working today. So let me see if I can find about the question and see what it said. So this is the question. All right, see the question here. The next part of the question is right here. See it here, guys. This part we're looking at now. And let's write information on here. Talking about the profit now. The question says, the owner of a shop sells the instruments to make a profit of $60 on each guitar and $100 on each violin. Let's go back up here so now. Now this is where we wrote the information. Let's put the information about the thing in black, about the profit. So in terms of the profit now, in terms of profit is making $60 on each guitar. See there? $60 each. $60 on one. And the violins is making $100. So the violin is making more money on each violin. $100 each. $100 each. All right, that is each. Don't mind the writing, just depend doing all kind of things. This is the technology, but we're still learning. So what would be if it's $60 on each guitar and $100 on each violin? Remember, he's doing X guitars and he's doing Y violins. Remember, 60 and 100. Let's write the expression for the profit down here. Expression for profit in part C. C part 1 is asking us for an expression for the profit. So we're going to say, all right, in C part 1, the profit, I'm going to call the profit P dollars. Somebody tell me what would P be equal to? Remember, it's $60 on each guitar and he has a profit of, he has X guitars, and it's $100 on each violin and he has Y violins. So what is his total profit? Give me an expression for the total profit in terms of X and Y. Somebody tell me.
Sir, could it read and say P equal 60X plus 100Y?
Beautiful. Beautiful. Just like that. Yes. 60X plus 100Y. That is the expression for profit. That is the expression for profit. Remember, you know, you can operate anywhere in the shaded region, you know. But what the question want is the maximum profit. They don't want profit anywhere. They want the maximum profit. All right. So now that we know what they want, so that's the expression for the profit. And that's the answer, you know. Very correct. Very correct. That's the expression for your profit. Part 2 now, we want to see now where in the shady region you can make the maximum profit. So we say can go back to the graph and look at it now. Bam. All right. So this is it now. Looking back at the graph now. So let's reason this out now. It's almost like common sense. Right? Let's read it out. We're going to use this marker to highlight what we're doing now. So we have those 3 vertices. Now remember, you know, him can operate in here, so you know, if you want, you know. And the 10 guitars and well, that would be like 7.5. Him can do 7.5, but you get the picture. Maybe here. Maybe undo that. So maybe here. This is you can operate anywhere inside this, all right? You can get full number of violins and guitars. But the question is now, one of these vertices is going to get his maximum profit. Question is, can he get maximum profit at this point? Where he has 5 violins and 5 guitars. Can he get maximum profit there?
No, sir.
No, because he's selling a small number. Good? Good. So that one is out of it. So it don't make no sense to analyze at point A. Is that at point B or point C is going to get the maximum profit? Now, why do we have to analyze both of them? Point A and point C to see which one it is. Why is it, we cannot just look and know exactly which one it is. We cannot just look and know which one it is, you know. We have to analyze to see which one it is, either B or at C. Why is it that we can't just look and know which one it is? Somebody tell me. Why is it that we can't not see it so just and guess which one it is?
Because one has a bigger value than the other, sir.
Good answer. I know what you're trying to say. This one has a higher Y value, while this one has a higher X value. See, the Y value for this one higher than this, but the X value for this one higher than that. So you can't just look and know. It's not safe to look and know. It's better you work it out. So always do a little test for maximum profit. Test and see which one it is. We know that it's B or C, you know. No makes sense to waste your time and do A, you know, because A definitely out of it, you know. So I'm going to use a red ink to test for the maximum profit. So we're going to test for maximum profit. I'm going to run a little test to see what it is. Profit. I will know that is B or C, right? So it's either at B, test a maximum profit at B, which is 1010, or C, which is 25. We don't know which one it is, so we have to test them, right? So already know. Profit at B would work out to what? Remember, it's 10, 10. We're going to put 10 here and put 10 here, because it's 10, 10. So it's going to be 60 times 10 plus 100 times 10. And what that work out to? Profit at B works out to what? It's a 1,600. 1,600. We know say dollars, but now put the dollar sign it. And I want to test C now, don't it? So the profit at C would be, C now is 25, right? 20 and 5. So it's going to be 60 times 20 plus 100 times 5. 100 times 5. What is work out to? It's that 1,200 plus 500. See that? 1,700 that, you know? 1,700, that's a 1,700. So the profit at C is 1,700. So you know, so bam, that's where you're gonna get the maximum profit. We don't stop there, you know. The question asks for the maximum profit. You have to state it. You have to state it in terms of dollar. And what is also good to do is state the conditions under which he gets the maximum profit. So he's getting his maximum profit at this point over here. The back of the graph is getting his maximum profit there at the point C, right here. When he operates 20 guitars and 5 violins. So if you want to do the business and make the maximum profit, you need to buy 20 guitars and 5 violins. That is always going to maximize this profit. So now that we know, I will finish with tests. We're going to write our conclusion now. So we're going to say, therefore, the maximum profit is, I put the dollar sign, $1,700 when, put the conditions, when, what are the conditions? 20 guitars and 5 violins are sold. And that is it. Soft. And I agree said soft. Must agree said soft. So don't think if you don't know if make it even soft as the what. Do another one. And do one more after that. And then do one more after that again. And again and again and again and again and again. Because more maths equals better maths. Right? So all we need to do now is just practice, practice, practice. All right. So you have the worksheet there. I want you to practice. I'm not finished it. I'm going to do another one. Let's do another one and show all this similar. All right. And trust me, the ones that are setting in the exam these days, much easier than these. They don't have so many things again like first time. This is a full shebang. They give you the statements. You have to write the inequality, right? You have to write the inequality. And after you write the inequality, you have to draw the graph. You have to put on the vertices and shade the region. Then tell about profit and all that. Then not set them like this no more. Or so wordy. I tend to make them look simpler nowadays. But if you can understand and do these, then the ones that you see in the exam these days now will be much easier. I don't want you just to learn how to do like a baby one. I said, you know, I want you to learn how to do more structured ones. I mean, when you get like a baby one, you just brush them aside. Soft, soft, soft. Brush them one side. So we have to practice and do the more structured questions. All right, so let us go and find another. Everybody good so far with this one? But all right? I don't know if everybody all right.
Sir.
Yes, sir.
All right, good. So I'm going to go and search for another one now. All right, let's search for another one. I might come back and use but this same graph again and erase that and do another one. All right, let's go and find another one. Let's find another one. All right, so this is another one. Let's see which one I'm going to do again. And remember, you know, guys, I wanted to practice all these questions. And at this stage now, we can actually practice them. So you have this worksheet in your handout. Those who have it, let me know. Let's see if I can get it to you. I want you to practice all these questions. More maths equals better maths. Try
Sir.
all of them. Yes?
You know it, sir.
Yeah, man. We'll talk after the send me a message afterwards and we'll work it out. It's in the booklet that you're supposed to get at the bookshop. Those who collecting at the bookshop. Other persons who are not collecting at the bookshop, let me know. And I get it to you. All right? These questions. You need to practice all these questions. If you can do all these questions, like a baby ones that they're setting in the exam these days, you'll brush it aside. All right? So I'm gonna find another nice one and do. And then on Wednesday, we're gonna do some more before I give you one to do for yourself. But let me find another one and do. So see this one, I give you a graph, and then you must read information from the graph. We're not doing that one yet. All right. Boom, bang, boom, bang. All right. Let me see. Just show. Just gonna give a graph again. All right. Let me see over this page what I give us here. All right. I'm just looking through them so I can pick one first. I'll just do one more for the day, you know. And then you remember, you know, the aim is you do the ones that I did first, and then you go and do the rest by yourself. All right. The same the two examples that I'm doing now. You're going to do those over by yourself first. All right. We could do that one here. Let's do this one. Can't float the thing. I don't know how to float it. So it stays on the screen. I need to experiment with this thing a little bit more. I'm floating it today, but it's not working now. Tested it and I floated it today and it's not working now. So we're gonna do that one next. All right, that's the one we're doing next. All right, so what I want to do, I want to put it on the left first. All right, let me do this. What's that? Find it back. Put it over there. Come back over here. Try back for this. And start a new one. All right, good. And let me zoom this up so everybody can see it. All right, so this is the one that we're doing now. Right there. All right, that's the one that we're doing now. Good. All right, so doing that question, one that says page 59. I'm gonna say that is basically the same thing. These questions are the same thing, you know. All right, sometimes I'm changing them a little bit, but if you can do this, you'll be able to do the baby ones in the exam, as I've been saying. All right. So this one says, the owner of a parking lot wishes to park X vans and Y cars for persons attending a function. So what is the information? X is the number of vans, Y is the number of cars. You don't know how many vans and you don't know how many cars. They're gonna give you the conditions under which he parks the vans and the cars. All right, so what we know is that he has X vans and Y cars, but we don't know X and we don't know Y. All right, so X vans, and Y cars he's parking. You write down information so you can reference it and don't forget. So X is the number of vans, Y is the number of cars. You don't know X and you don't know Y. You don't know how many. It says, the lot provides parking space for no more than 60 vehicles. You can't hold more than 60. That means the total number of vehicles is 60 or less. No more than 60. See there? No more than 60 vehicles. See there? No more than 60. That means 60 or less. And you see the word vehicles is taken to mean the vans and the cars together. All right, and see, you know, they want us to write an inequality for that information. So talk to me now. What is that information for part one? What is that? What do we need? What do we know from that information for part one? The number of vehicles must be no more than 60. Vehicles is thing to me the sum of the number of vans and the number of cars. Somebody tell me now. Get good now, you know. Tell me.
There must be
But you're writing an inequality, you know, to represent information.
less than or
Something in
equal
terms
to
of x.
60.
Huh?
X.
What
Less
must
than
be
or
less?
equal to
What?
60.
Why x? It's a vehicles. See? Remember I'm parking vans and cars, you know. Vans and cars. And vehicles is thing to mean the vans and the cars. All the vans and all the cars. What would if x is the number of vans and y is the number of cars? What would be the total?
So
X
x
plus
plus
y.
y.
All right, lovely. So it's x plus y. That's the vehicles. Vans and cars together must be less than or equal to 60. Can't have more than 60 in the parking lot. That's the first inequality. Done. All right, good. Next one. To get a good bargain, you must provide parking space for at least 10 cars. So for example, 10 boss man will drive car. Come and say if you leave 10 space for we, you know, I'll give you an extra bonus. I'll give you a little thing or something like that. I will give you a deal, I will pay you more. Some kind of deal. To get a good bargain, you must provide parking space for at least 10 cars. At least 10 cars. Remember, if you must have at least $10 to go to the party, that means you must have 10 or more dollars. So at least 10 cars means that the number of cars must be at least 10. Means 10 or more. What represents the number of cars? Inequality number 2.
Y is x plus 10y. Yeah.
Come on, think, man, think. Don't stop, think. The number of cars is provide parking space for at least 10 cars. Cars, now we're talking about the cars. Cars. The
10y
cars.
is greater
No,
than
man.
or equal to.
No, here we need to do. Let me tell you what you need to do. Let me tell you what you need to do. You need to just say what the statement means first. The number of cars. Remember, you know, this is about a number of vans and a number of cars, you know. You always start that way. The number of this and the number of that. Because this linear programming question is always about number of one thing and number of something else. Number of something and number of something else. So all this inequality say, you know, is that the number of cars, which is y. Y is the number of cars. The number of cars must be at least 10. So y, which means the number of cars, must be at least 10, which means greater than or equal to 10. It's as simple as that. The number of cars, which is y, must be at least 10. That means greater than or equal to 10. Simple enough. Simple. I know you're just learning it, and I like how you're trying. Keep going, you get it. But that's what it means. You understand it? This statement means the number of cars must be at least 10. That's a mathematical representation for that statement. The number of cars. Remember, y is the number of cars and x is the number of vans. This condition is talking about the number of cars. Must be at least 10. Good? So that's your second inequality right there. That's the second inequality right there. So far, so good? Are you good so far?
Yes, sir.
Remember, now, I want to do over these questions. The 2 examples that I'm doing now, I want to do them over first, you know, before you try the others, you know. Do over the same 2 examples first. All right, next one. Third one says the number of cars parked. The number of cars parked. Remember, the number of cars is x. No, the number of cars is y. The number of cars parked must be fewer than or equal to twice the number of vans parked. What does that mean? They're giving you this inequality straight. Don't mix up business. They tell you straight what's supposed to happen on the third one. The number of cars parked must be fewer than, mean less than, or equal to twice the number of vans. Come on, the most can tell me that one. That one is straightforward. Come on, let me hear what you say. The number of cars parked. Yes.
So it would say y is less than or equal to 2x.
Very good. Beautiful. Simple as that. The number of cars must be fewer than or equal to twice the number of vans. That's what you write it there. That statement there, that inequality represents what they just said. Simple as that. Those are our three inequalities. Nice and easy. And then as usual, they're gonna want us to put them on a graph. See there? See? So after we get the three inequalities, I want us to show them on a graph. It says, using a scale of 2 centimeters to represent 10 vans on the horizontal axis, and that's why they give vans X on the horizontal axis, and 2 centimeters to represent 10 cars on the y axis. That's why they'll use Y cars, Y for the cars. We are to draw the graphs of the lines associated with the inequalities in 1, 2, and 3. So basically, I want us to draw these three, the lines associated with those three inequalities. And then after that, I want us to identify by shading the region that satisfies all three. So we're going to shade a common region. The region that satisfies all three is called common region. And then down here, you know, they might tell about some parking, some fees down here. Some fees down here. All right. Maybe what I need to do is put what we're gonna put on the graph, put in information about the fees, and then we'll go to the graph because I don't have the mix-up. That's what a while ago. So I could just put in what we're gonna put for the graph first. Let's put that in red, right here, and blue again, right here. So what we're gonna put for this, we're gonna represent this graph now. Talk to me. This one. We're gonna represent that one on the graph. Talk to me. How we're going to represent that one on the graph? Put in how we're going to represent that one on the graph. Talk to me. We're going to represent that inequality to the graph.
X plus y equal to 60.
No. Listen to me now. Make it stick. Inequality on a graph is about being above or below a line. So the first word out of your mouth must always be either above or below.
That's below, sir.
Below.
Good. Below. The second thing is whether you're gonna be drawing a
Unbroken
broken
or
line.
okay.
Good. And the third thing was which line you're gonna draw. Follow that sequence, I don't have a problem. So the first thing is that good. Whatever is positive, the less than means below. Good. So we're going below. Below. And we're gonna be broken or unbroken.
Unbroken.
Unbroken because the equal is there. So you want a solid
Yes,
line. The line is apart. So you're gonna go unbroken. Unbroken. The line is a part of inequality. And which line are we drawing? Which line? What's the line? What is the line that's associated with this inequality? What's the equation of that line?
Vertical.
X plus y equals 60, sir.
Exactly. X plus y equals 60. And this line is an x plus y line. So it's one of the easy lines. So it passes through 0, 60, yeah? And it passes through 60, 0. That's an x plus y line. Simple, because when this is 0, this equals 60. And when this is 0, this equals 60. So it passes through those 2 points. This one is on the y-axis, and this one is on the x-axis. The x plus y lines are an easy line to draw. Cross the y-axis and x-axis at this value. All right, easy. All right, the second one now. Boom. Ready again. Above or below? First thing is always above or below.
Above.
Talk to me.
Above, sir.
Above. Whatever here is positive, greater than means above. So we're going above this line. Above. Above. Broken or unbroken?
Unbroken.
Unbroken. All of them unbroken. See that? Unbroken, unbroken, unbroken. So all of them unbroken. Because the equal is there on all of them, right? So unbroken. Unbroken or a solid line. It means that the lines are valid. Points on the lines are valid points. Unbroken. And then the line we're drawing is which line? Which line? Which line is it? What's the equation of the line? That's
Sir,
associated
y
with this.
equals 10.
Y equals 10. Very good. A horizontal or vertical line that? Horizontal or vertical line? Y equals 10. Huh?
Horizontal.
Very good. That's the horizontal line passing through 10. Yeah, man, horizontal line. Remember, x-axis. Remember, the x-axis is y equals 0. Good. So any line of horizontal or y equals 0 will be horizontal at the x-axis. All right. You will get it with practice. Don't worry yourself. All right. This one now, down here. This one now. Talk to me now. Ready again. Above or below? First thing is always above or below. Eh?
Below.
Whatever here is positive, less than means below. Good. So that one is below.
And it's unbroken.
Very good. Unbroken.
Because it's equal to 2. Y equal to.
And the line is y equals 2x. Very good. Y equals 2x. And then we need 2 points for this. And one of the point clearly is 0, 0, because there's no c value, don't it?
Yes,
one of the point is, and then for the next point, okay, I put in an x value. For example, the x value of 30. And say 2 times 30 is 60, right? 60.
yes, sir.
Simple as that. All right. And we use 60 because of this equation. We know so we have to go up to 60. That's how we can use values going all the way up to 60. Understand? That's how you can know that is 30 and 60 you use. All right. So 30, 60. All right. So we're gonna draw that. So we're gonna need the vertices. So let me put down what we're gonna need because I don't want to take off this until already. Let's talk about let's talk about the fees down here first before we're going further. The fees down at this part. Let's talk about down here first and put it up here. So in terms of the fees, let's write the fees in red. In terms of the fees that they paid. In terms of the fees, right? The fees for the vans is $6 for a van. A van, $6, meaning one. So it's $6 each for the fees for the van. $6 each. And the cars, a car is $5. So the fee for parking a car is $5. So it's cars, $5 each. All right, so let's put on some information down here that we know we're gonna need. So from the graph of part 4, we're gonna do the graph. We're gonna do the graph next. All right, we're gonna do the graph and then we're gonna shade it. We're gonna put these after because the thing I'm not able to float the thing. So I just write what we're gonna do next. I'm gonna remove this now afterwards and just keep this and the graph on the page, right? So I'm just writing what we need for the question. So we're gonna shade the region. And we know that we're gonna need the vertices. So for part 5, we're gonna need the expression for the fees. So we can do it from now, for part 5 right here. We need an expression for the fees. So the total fees, let's try to do it from now. Total fees. F dollars. So let's look at it now. So it's $6 each van. And it is $5 each car. And it is X vans at $6 each and Y cars at $5 each. So what will be the total fees? Remember, it's $6 for the vans each and $5 for the car. What will be the total fees down here? Talk to me. What will be the expression for the total fees? That's what I want us to write in part 5. Expression for the total fees. Expression for the total fees. We're calling the total fees F dollars. So talk to me now. What will F be equal to? Somebody tell me.
Sir, F would be equal to 6x plus 5y.
6x plus 5y. Very good. That's it. 6x plus 5y. That's going to give you your total fees. Then the graphs, then part 5 says, using your graph, write down the coordinates of the vertices. You see that? So I'm going to put a section for that. I'm going to do it afterwards, right? So part 6, we're going to do our vertices right here. When we reach it, vertices. I'll leave some space for the vertices and come back and do it. And then part 7, they want us to calculate the maximum fees. So for part 7, we are going to have to do a little test. We're going to have to remember test first. Test for maximum, maximum fees. Always do a test first. And then after we do the test, we want to declare what the maximum is down there, right? All right, so we know what we're going to do now. So we're going to do the graph and the shaded region next. So we're going to do the graph now based on these things that we did up here. All right, so we could go now and deal with that. So I'm going to do this. I'm going to do that. And then I'm going to do that. I'm going to put that over there. And then I'm going to go for my graph. That's my graph. What I'm going to do for the graph, I'm going to erase what we had before. All right, I'm going to erase these things. I think I can erase it like this. All right, not allowing me. All right, let's do it like this. All right, so I'm not losing the lines. I'm not losing the lines. I need to change the scale as well. Remember? I have to change the scale as well. And this have to go. All right, so that's what I have. So I can maybe use about these 2 lines. All right, so all right. I can maybe use about these 2 lines. Let's put them up here for the time being. I'm going to use about these 2 lines, right? So the first thing I want to do is to put in the scale. Remember the scale said 2 centimeters to 10 for this one. It said 2 centimeters to 10. That's what the question said for this one. 2 centimeters to 10. Let's go back for the blue. Go back for the blue right here. I'm going to put in the 10 down here. So it's 10, 20, 2 centimeters to 10. So this is 10, 20, 30, 40, 50, 60, 70. And then up here on the same thing. 10, 20, 30, 40, 50, 60, 70. So the question said 2 centimeters to 10 units. That's what the question said, right? Let's look and see if that's what it said. Let's look. See here, 2 centimeters to 10 vans and 2 centimeters to 10 cars. All right, so I'm right. That's what it said. So that's what we use it. 2 centimeters. That's 2 centimeters and 1, 2. 2 centimeters to 10. All right, so that's the scale that we're using. All right, so then now we're gonna put in the lines. I'm gonna just copy these lines and put them in. Now the first line was the x plus y line. X plus y equals 60. So I'm gonna use this one. I'm gonna use this one. So I'm gonna put this point at 60 right there. I'm gonna put this point at 60 down here. All right, and that's it. I can extend it like that. That's the first line. X plus y equals 60. What do you do next? Label the line with the equal sign. So this line is x plus y equals 60. Always label the line with the equal sign. The line is the equal mark. The second line is y equals 10. I will have 2 lines. Let's see if I can copy this one. Let's see if I can. But when I duplicate, all right. So, all right, I'm gonna use this 2. Let's this one. Next one is y equals 10. Remember, see it here? Over here, sir. Y equals 10. First, though, let us put an arrow. First, let us put an arrow on this line pointing down, because it was below. Below. I want to put an arrow on this line pointing down. That means that I want below this line use the same color. Let's use the same color as the line for it. So I put the arrow on this line pointing down. That means that I want somewhere under here, below that line, eh? That's what I want. The next line though is this one. Y equals 10. Y equals 10 is a horizontal line passing through 10. My bad. Y equals 10. See there? Horizontal line passing through 10. That's it. That's the line y equals 10. So you have to draw it on a graph paper, you know. Label the line with the equal sign. Label the line with the equal sign. So y equals 10. That's that line. Let me relabel this one down here with the same color. Not allow me to erase it. Why? I just think this one thing sometimes I can understand. Anyway, all right. The next line I want above that line, right? Above. Y equals 10 was above. So I'm going above this line. So I put an arrow pointing up. Like that. So the region I want now is somewhere inside here. When I finish it, I'll put in the next one first. Right? I'm narrowing down on the area and the region that I want. I'll put in the next one first, which is this one now. Which was the y equals 2x. And what did we say? Y equals 2x passed through 0, 0, and it passed through 36. So we're going to use this and move this down to 0, 0. Move this point down to 0, 0 right here. And then move this point up to 36. So you have to plot the points and draw them out. 36. That's it. And then what I can do is also extend this line. That's it. Well, understand that? What good? Let me put it right at the 30, 0. And put it right at the 30, 60, so you can see better. That's it. So remember, we plotted this point and this point for that line. Right? And then this one, the pass to the 0, 60, 60, 0, and the 0, 60. So those are the points. They label the line with the equal sign. This line is y equals 2x. And the one below this line, so you put the arrow pointing down. All right, so the only one giving me a little bit of trouble is this one. Let's see if we can write over it. X plus y equals 60. Can't go any further. Not allowing me to go any further. All right, not allowing me to go any further. But anyway, you can see now that you want below this line, above this line, and below this line. So clearly the region they want is inside a triangle right there. So let's shade that triangle with a color. Let's use the blue, this blue. So I'm gonna shade it inside here now. Like this. That is my region that I want. That is my shady region. All right, so we have completed this part of it, which is to draw the graph, and this part of it, which is to shade. So I've drawn the lines associated with inequality, and I've shaded the region that satisfies all the three inequalities. All right, now we've got an expression for the fees. This is it. We did that part already. Expression for the fees. And the next part now is for us to write the vertices. All right, we're going to write the vertices. So come back over here now on the graph. We're going to go now and we're going to write the vertices. And we're going to give them letters again. I always give them letters. All right, so this one, as usual, I'm gonna call this one A, call that one the point A, and that clearly is a point 510. 510. Where did I get that? A is 510. And then B right here, that is 2040. B right here is 2040. I'm gonna call this one B. And it is 2040. 2040. And then this one down here is C right here. And that is 5010. C point C is 5010. Those are your points. So let's write them over here now. So the vertices are A 510, B 2060, no 2040, sorry. 2040. Mute the mic, please. And C is the point 5010. 5010. Good. Those are the three vertices. And then now the last part now says we have to calculate the maximum fees. Now remember, this is the formula for the fees, you know. This. Let's write it back down here. So I want to test for the fees now. Test for maximum fees. The fees formula is 6x plus 5y. 6x plus 5y is the formula for the fees. Now look at it now. Can this vertex, let me use the orange now again. Can this vertex down here give me the maximum fee? Can that vertex give me the maximum fee?
No, sir.
No, because it have the lowest number of cars and vans parked. All right? So that one out of it. It don't make no sense to waste time and check that one. My maximum fee is going to be either at this point or at this point. One of those two. One of those two is going to get my maximum fee. If you notice, total vehicles parked at each of them is 60. See, 60, up to 60, and this up to 60. Right? Because they're on the line where x plus y equals 60 down here. You can see it. Gone outside the thing. That's it. All right. So it's one of those 2 points. I have to test those 2 points to see which one it is. Test those 2 points to see what it is, which one it is. I'm going to do my test over here now. All right. So I'm going to test B first. So B is a point. I have it up here. B is a point. B is a point 2040. So my fee at B would be 6 times the 20 plus 5 times the 40. Right? And that would work out to what? This is 201.20. That's a 201.20. That's what, 320? That's 320. 320 will be my fees at B. All right. Then I'm going to test my C next. C point. C, which is 5010. My fees at C would be 6 times the 50 plus 5 times the 10. So basically putting the x and y values in the formula now. X, y for that one. And then x, y for that one, for the second one. That's how we get these. Now this is 350. 350. So this one is 350. So clearly, second one you want. Right? And we'll stop there for answer the question. So go back now. That was just your test. That there was just your test. When you finish, you're going to write the solution now. You're going to say, therefore, Therefore, maximum fees is, put the dollar sign, $350, put the conditions when, which one come first again? The X was what? X was a van. X is a van, right? See, the X is a van and the Y is a car. See there? Make sure the X is a van and the Y is a car. So when 50 vans and 10 cars are parked, when 50 vans and 10 cars are parked. And that's it. Nice and easy. Oh, yes, dear guys. Everybody good?
Yes, sir.
Yes, sir.
Yes, then.
All right. I know it's not tired enough, but there you go. You have to work hard so the exam get easy. That's just the nature of the subject, right? You want the exam to be easy. You work hard, study hard, pass the exam easily. That's how it goes. All right, because more maths equals better maths. So I hope you understand it. You should understand it better today. But we still don't attain mastery as yet. All right, so we still have to go and practice more. So I said your homework right now is to go and do these 2 questions that I did. Do those 2 questions first as a first objective. Right, and then after you complete those 2 questions and about the same answer that I got, then you can go and try the others. Now I'm going to post the video as soon as it's available, and you can use the video as your revision. All right, that's one of the beauty about the online thing. Now you can actually, revise the class, watch over the class again. That's the beauty of the online class. You can actually almost like you're attending the class again. And you can fast forward and rewind and go up to any section anyone understands so clearly. All right, so make sure you use up the facility. Remember, the video is not going to stay up there very long, because I have a limited space on the Zoom cloud site. So you have to go and make sure that you go and look back at what you need to look at quickly. Sooner the better. All right, so that's it for today, guys. I'm going to see you all on Wednesday, and we shall improve on this thing and make it even better. So we're going to start the class on Wednesday by doing a number of questions. See if we can do 3 or 4 questions on Wednesday, right? And then I'm going to give you one to do for yourself. And when you do it, you send me your solutions. All right?
Yes, sir.
Everybody good? Feeling any more confident? Last class you were saying don't feel so confident. Feeling any better today?
Yes,
Yes,
then.
sir.
Yes. Right. You're supposed to feel like a bit more confident, and yet still the more we do, the more the confidence will come. All right, until you can breeze through these questions. And believe me, as I tell you, these questions are getting easier the more recent exams. These questions are like from the older exams, and the questions were more structured. They're not so structured anymore. So they tend to be easier nowadays. So I wanted you to be able to do these more structured ones, so that the easier ones now you can breeze through them. All right, so that's it, guys. See you all on Wednesday. Bye.
Bye, then.
Bye, princess.
Yes, sir.
All right, cool.
Yes, sir.
Bye. All righty.